Oh, hey everyone, today is my channel here, and today we're going to be going through negative values, complementary angles, and exact values. Um, Sorry about the I've kind of lost my voice a bit, but I guess you just have to put up with it. Okay, so this is a continuation of the introduction to trigonometric functions. So if we go on here, the negative values. So when we calculated the angles the first time in trigonometric functions, we started quadrant one to the top right of the plane. Then we went anti-clockwise. So a negative value is kind of the opposite of that. So instead of clockwise, we're going clockwise. So quadrants 4, 3, 2, 1 instead of 1, 2, 3, 4. The new rules here are sort of so cos of negative theta equals cos theta, and this is intuitively makes sense because in quadrant 4 and quadrant 1, we're studying different quadrants, but the cosine values are still the same. Sine of negative theta equals negative sine of theta. In quadrant 4 it's a negative sign, and positive in quadrant 1 it is positive. And tan negative theta is negative tan of theta, and because tan is sine over cos, the fact that sine is negative means that tan will also be negative. And this relationship here that you see holds true for regardless of what quadrant you're in. So for example, we have a angle. The example is we have sine theta equals root 3 on 2, and the question asks you to find what's sine of pi plus theta. So one of the things to realize is that sine pi plus the theta is in quadrant 3. So sine of pi plus theta equals negative sine of theta. So it's negative root 3 over 2. Negative 3 over 2. So if we have find if this is sine of theta, find tan of theta. And so you know that tan of theta equals sine of theta divided by cos of theta. If you note that from the previous video, sine squared theta plus cos squared theta equals 1. And you put cos squared of theta as the subject, sub in root 3 over 2 as sine, and you square root the whole thing, your answer cos of theta is 1 over 2. When you divide it, the square root of negative 3 on 2, divided by 1 over 2, you get tan of theta is root 3. So the complementary angles. So in the first video of trigonometric functions, we saw how it was 0 pi plus theta, or pi plus theta, or pi minus theta. So it's related to the x-axis. So in complementary angles the angles are related to the y-axis rather than the x-axis. So you can see here the theta is on this side, like, towards the y rather than on the x. So these are the rules for the, quadrant 1. So cosine of pi over 2 minus theta equals sine of theta. Sine of pi over 2 minus theta equals cos theta. And tan pi over 2 minus theta is 1 over tan theta. And when we think about it, intuitively it makes sense. So if we have this triangle here on the left, and this part is theta, cosine is adjacent over hypotenuse. So the hypotenuse is 1, adjacent is actually the y value, the sine. And sine is same is true of sine. And this is what means like complementary, because these angles theta and the pi over 2 minus theta add us up to 90 degrees. And because sine and theta sine and cos are swapped in complementary angles, that's why this becomes tan pi over 2 minus theta becomes 1 over tan theta. So quadrant 2, these are just the following rules. So from here, this is sort of the triangle of reference. So in the middle of the diagram here, the light blue triangle is the angle of reference. The triangle of reference. You can relate the rest of the quadrant rules. Have a quick look at them. You can relate the rest of the quadrant rules into the quadrant rules, and you can kind of see, you can work out for yourself why these rules are true. And lastly, exact values. So in the unit circle, we talked about how a circle of radius 1 unit is circumference of 2 pi. So you know that a straight angle is would be a straight angle would have an angle of pi, because 360 degrees is 2 pi, therefore 180 degrees is pi. And from that you can also generalize that 60 degrees is pi over 3, 45 degrees is pi on 4, and 30 degrees is pi on 6. And this is where you get these angles. So for example here we talked about sine is theta is root 3 on 2. So you have root 3, you have root 3 here, you have root 2 here. You can calculate it for yourself and realize that this would be sine is opposite over hypotenuse, so root 3 over root 2, and that would be sine at 60 degrees or sine pi on 3. and that's sine pi on 3. Then cosine theta here will be 1 over 2, so just the cosine of pi on 3 is 1 over 2. Here, as you see, this equilateral triangle of side lengths of 2 split into half, and that's how you get and you get root 3 and 1 from Pythagoras' theorem. And I guess lastly of all, this is just the this is the angles of conversion, as I did before. And these are just the answers to the values. When you're working out, often as a general rule of thumb, it's best to put a so for example here 45 plus pi over 4 of sine is 1 over root 2. It's better for you to convert the whole thing into a proper fraction, so have instead of 1 over root 2 have root 2 on 2. I know it's just a thing that most math teachers prefer, but if your math teacher doesn't do it, then that's fine. Okay, so we're just going to go through example here. So it says solve sine of 11 over 3 of pi. So what you want to do is you want to rewrite this. So 11 over 3 pi is the same as 4 pi minus 3 pi. And because the circumference of a unit circle is 2 pi, we can get rid of 2 pi away from this. So technically these two are the same. Here following the rules above. So sine 2 pi minus pi on 3 is negative sine of pi theta. So pi on 3. Therefore the answer is negative root 3 over 2. And yeah, that'll be all.